Okay, today lesson 48A. This happens to be the last lesson of Unit 3. So that means after today we start getting ready for our Unit 3 final exam. Unit 3 final exam will be Friday, by the way. And so we continue with word problems that involve multi-step equations. And so what we're doing today is just an extension on what we talked about yesterday. Okay, so let's go ahead and continue on here. Much like yesterday, these ideas of increases and decreases and markups and markdowns and discounts and tax and all of that stuff, you still have to keep those things in mind in terms of what does it do for the actual percent. In other words, we always start at 100% and then we either increase that value or we decrease that value depending on the context of the problem that we're talking about. And so here would have been a problem that we talked about yesterday where we have a person buying a smartphone for $291.20. That was the increased price after a markup of 12%. And so we talked about it in terms of a tape diagram as a way of modeling the situation where we don't know the price. But we do know that after they had an increase or a markup of 12%, that the cost of that item was $291.20. And we use that as a way or a very beginning of trying to figure out how to set up an equation for that situation. And once we have that equation, we simply solve the equation. And what we were trying to do yesterday is we were trying to understand that all of these problems were really a comparison of an original amount to a new amount. And so in this particular situation, the $291.20, that was the new amount because that was the amount after it had been marked up. And what that meant is we did not know the original amount. But what we do know is that after we mark it up, that original amount, 12%, which takes us to 112%, that value was $291.20. And that's probably the fastest way of getting to an equation that we can quickly use to solve. Okay? All right. So number one is really just an extension on what we talked about yesterday. So could I get all of you to set up and solve number one? So we're going to kind of go in reverse order from where we were yesterday. We're going to start with the fastest way, and then I'll just kind of quickly show you a tape diagram to solidify the modeling part of this. And so in this problem, once again, we're comparing the original to the new amount. That $328 is the original amount. We don't know the new amount. And this is how every problem starts. And then we always do something to the original amount, regardless of whether we know what it is, like we do in this case, or not. And so if we get an 18% discount, that's taking away 18% from the 100%, so that leaves 82%. So to find the price, or the new price, it's simply 0.82 times 328. Another way of looking at it is we're trying to find 82% of 328 to find the new price. But regardless, it's $268.96. That's how much he's going to pay, which is an 18% discount from $328. Now, in terms of a tape diagram, that looks something like this, and I'm not telling you that you have to copy this down. I just want you to look up here. So we take the $328, and we're going to take 18% away from that, and that's found by multiplying 0.18 times 328, and we take that from 328, and that's just another way of getting us to that $268.96. All right, and so now we're going to go to another problem we talked about yesterday, and then we're going to extend off of this one for number two. So yesterday we had a problem that went something like this. Drake bought a skateboard. We don't know the original amount. All we know is that it was on sale for 20% off, and he ended up paying $109.60. Which, by the way, we're going to use that amount for number two. And so when we did that, we modeled it with a tape diagram to show that what was left was 80% or 0.8s, and then we use that as an equation to All right, back up front. Everything we do is to the original. So everything that we do is all done over here on this side. Okay? All right, back up front. We already decided that 270 is the number we're dealing with. That's 4 hours and 30 minutes. 270 minutes. By the way, is that the original time or is that the new time? I mean, even if you didn't know that, look at the last 5 words in the problem. What was her original time? That's what you're trying to find, is the original. So that means the 270 has to be the new. Please also recognize that the way we're trying to get to these the fastest way possible. And so therefore there is no adding or subtracting, right? I mean, I realize that you might be adding a percent in your head, but that final equation is all about multiplying. So in today's problems, it'll be something times something times something equals something. Now, the question is whether the variable's on the left-hand side or the right-hand side. That's the only question. And if you're adding a percent onto 100% or subtracting and then converting those to a decimal. All right, so I want you to finish the setup with your shoulder partner. And then once we decide we've got the right equation, then we'll compare. You'll compare with me, and then I'll let you finish it. So come up with the final equation with your shoulder partner. So we are asked to find the original time, which means we don't know what the original time is, which also means that 4 hours and 30 minutes, that 270 minutes, is the new amount. It's not the original amount, because that's what we're trying to find. And so here's the initial setup. Some variable, and in our homework we have to use x, but I'm using t because it represents time. And then we're going to do something with that left-hand side of our equation. So now if we go on to read through the problem, the next time she ran a full marathon, she cut about 25% off of the original time. So if she cut 25% off, what percent does that leave us with? 75%. So that means we're going to multiply the variable on the left-hand side by 0.75. And then after you take all of that, it then goes on to say that she reduced her time by an additional 10%. So if she cut that time off by 10%, what does that leave her with? 65. And I knew somebody would say 65. We're now starting brand new. It's of this entire amount. She cut 10% off of that entire amount. What does that leave her with? Well, give me it as a percent.
90%.
It's 90%, right. And then we use 0.9. So that whole entire amount, we're finding 90% of that. And so that's why it looks like this. So we have 0.9 times 0.75 times your variable equals 270. That represents 75% of her original time, and then 90% of that is equal to 270. So I'm going to let you finish it. So from here, we need to multiply once again. 0.9 times 0.75, that's 0.675. So we have 0.675 times your variable equals 270. Divide both sides by the 0.675, and you should get 400. So in the context of this problem, that means her original time was 400 minutes. Some of you converted it to hours and minutes. It doesn't really matter. 400 minutes is perfectly fine. Now, if you had done this with a tape diagram, it would look something like this. So you start with your tape diagram. You don't know her original time, but you know that when you take 75% of that, which looks like this, and then of that, take 90% of that, it looks something like this. And that's kind of another way of looking at what leads us to our correct equation. Something you don't know, 75% of that, and then of that, 90%. And if you look at the equation, that should make sense. And then the answer to all of that is supposed to be 270. All right, let's go to number 4. Just like the last one. Read it, set it up, don't solve it yet. So we have this person who sells 200 cupcakes a week. We have to figure out whether that is the original amount or the new amount. And that is the original amount that she started with. So we don't know the new amount, so let's use a variable right there. In the homework, we have to use x. I'm using c in this one. And then it said the first of the 2 weeks, she increased her sales by 10%. If you're increasing 10%, that takes you to 110%. Which as a decimal is 1.1. So we're finding 110% of that 200. And then the next week, the second week, she increases that value by another 10%. So of the 1.1 times 200, we're going to increase that by 10%. And so we essentially have 1.1 times 1.1 times 200. And once again, we have another situation where it's okay to multiply out of order because of the commutative property, so I'm going to let you finish it from there. And then we have one problem left. So I heard from most of you 242, so I'm going to assume that that is correct, and it is correct. 1.1 times 1.1 times 200 is 242. If you were to use a tape diagram, here's what you would have to do. You would start with the first situation and add 10% onto that. So 10% added on to 200 is another 20 cupcakes. So that now takes us to 220 cupcakes. That's after the first week. And then you take that value and have a new tape diagram and add 10% onto that. And so that takes a little bit more work, but you can still get to 242 because 10% of 220 is 22, and 22 added on to 220 is 242 cupcakes. All right, last problem. We're going to work this one the same way that we've worked the previous few. I want you to set up the equation that you think will work to solve. We'll compare with our shoulder partner, and then we will finish it off. So remember, we need to start with that 252, which is the amount paid for the snowboard, and that is, and I thought I had... Let me back off here because I thought I had the short part first. That 252 is the new amount because that's the ending amount that he paid for the snowboard, which means that we don't know the original cost. Plus, it says, what was the original cost? Then from there, we've got a 30% off. It's on sale for 30% off. If something is on sale for 30% off, that leaves 70%. And then, after you take the 30% off, now it's on sale for an additional 20% off. So out of all of that, if you take 20% off, that leaves 80%. Now you can finish it. All right, let's take a look at what we have here. So we have 0.56x equals 252. We divide both sides by 0.56, and I believe that 252 divided by 0.56 is 450. Is that correct?
Yes.
And so that means the original cost of the snowboard was $450. All right, we are finished for today.